All right. Hello, everyone, and welcome to another live stream about IncusOS and the ongoing development of it. As a bit of a reminder, last week I started tackling support for services and specifically looking at the NVMe of a TCP service to try and get those devices showing up on Incus with an API to configure it. I've not had much time to spend on that since, so today is going to be mostly picking up where we left off, but that doesn't mean that nothing happened in the past week. Actually, as you might see on screen here, something happened just a minute ago where I merged another new feature for IncusOS. So we're gonna go through what happened over the past week. Just changing a monitor setting here. There we go. And then pick things up on the services side and keep going with that. I think I mentioned last week I was going to be reinstalling my desktop. That has happened, so do let me know if anything doesn't seem to work as usual. I did record a couple of videos, I think, with the new setup, so it seems to be working fine, but yeah, let me know if anything wonky is going on. All right, let's look at what happened since over the past week and also look at some of the open and upcoming pieces of work that we have on there. So let's go to what was last week. We are currently the 17th, so we're looking for the 10th-ish, so that would put us right around then. The networking config, I think I had already landed. Textual multiplexing, I don't remember if that was landed already. April 11th, 5 p.m. So I guess not. So that was added so that we can now see the text UI both on the console device and on the VGA console. So I'll show you that in a tiny bit. It's working just fine. And then some of the initial kind of work I did last week did land, but as mentioned, not the full service API. So that means that there's been a bit of reshuffling on how to spawn images that had already pending on my branch. NVMe, the NVMe tools are now included. A few more tweaks to Golang CI. I think that one I fixed during the live stream last week. Tweaked some of the nested struct and just put in place some of the filtering on the REST API. So those were kind of prepared during the live stream last week and then got merged shortly afterwards. And then what else happened since? So we've added support for configuring the hostname and domain on a sudo network config. Also expanded a bit on some other fronts. So cleaning up the way we handle structs within the text UI to just connect things a bit better and making it easier to manage. Added support for AppArmor. So that was something, I think I mentioned it last week, or I did mention it recently, where AppArmor was not enabled and it needed a bit of trickery to make it work. So Matthias did that. This is not working fine now. Tweaked the package source. For some reason, we're still using the daily packages from Incus instead of stable, so that's been switched over to stable now. Also, instead of saying testing, we're using Trixie specifically, so that when it does go stable, we don't end up being moved over to the new testing. And just now, so just a few minutes ago, I merged an API change to add the ability to change the network config through the API. So both retrieving the network config and pushing it back. So that's where we're at. Now, if we look at what we've got in front of us, a few things. So the services API, that's what I've been working on. That's what we'll keep doing in this live stream today. But there are a few more things that have been open since, and most of which Matthias is looking at doing. So there's more on the network front. We've got network config working, but there's some pretty obvious things that are still missing, like static DNS is one thing we need to add. Configuring NTP is something else that we need to add, and supporting HTTP proxies. At that point, we should be able to do a pretty simple check of actually setting all of those correctly. then restarting the system and making sure that it doesn't try to reach to anything other than those configured servers. Like we want to make sure that there is no leftover services or something running on the machine that's calling home or that's pulling stuff from the internet. This is pretty critical because we expect IncusOS to be used in corporate environments, like heavily firewall environments, air-gapped type environments. We want to make sure that there's nothing that we're unaware of. So there's that coming pretty soon. On the OS and application side of things, we want to actually start looking for updates and putting them automatically. So the idea is to do something kind of similar to the default policy on Incus, and every 6 hours we'd go check if there's an updated version of the applications. If there is, we'll just go and download and apply it immediately. If there's an update to the operating system itself, then we would download that and stage it. So I put it on the other set of partitions and then put a message in the text UI, making it clear that a reboot is required and effectively trying to nudge the user into doing it that way. Once we've got that, we're going to be working on an API as well so that it's actually possible to look at the updates, change some of the policies, and just manage things directly that way. So that's on the update side. Then this one will cover last. Encryption recovery mechanism. So that's another thing for it to be useful for anyone who's not just testing it in a VM like we are for development. The storage is fully encrypted on IncusOS and it's tied to TPM state. That's nice, but if you go and change anything on the system and that TPM state no longer lines up, now you've got a disk that you can't access. I'm reasonably sure that we currently enroll an empty key, so if you just hit enter, it will work, but that's obviously not safe. So we want to clear that, remove that empty key, generate a random key, pretty similar to a BitLocker recovery key on the Windows side, and then have an eye to query those keys and also be able to change things if needed. All right, I'm hoping the stream still works because I just got a notification from Google that I disconnected from the dashboard, so that's slightly odd. Hopefully things still behaves. I'm just gonna check the network here to make sure I don't have connectivity issues. No, my network seems fine. So hopefully it's just Google freaking out, the live streaming dashboard anyways. Okay. All right. So I'm back on the dashboard. I'm seeing, just checking what's going on with the streaming. It shows poor quality on the stream side. Not too sure why. My desktop shows it's pushing 6 megabit just fine. All right. Anyway, anyone in the chat, just let me know if there's anything going on with the stream. It's kind of hard to tell if it's just the Google dashboard having an issue, which has been known to happen, or if there's an actual problem going on right now with the stream. Okay, so the stream paused for a bit and then resumed. Okay, that's not very encouraging, to be honest, but hopefully things recover from there. All right. Yeah, and I see it's excellent quality. Things are fine now. Okay, not sure what that was about, but sure. All right. Yeah, recovery key management. That's what I was at. We're gonna have an API to fetch the automatically generated recovery key. We're gonna show a warning on screen until it's been recovered. Once you recover it, then we clear the warning, and the API also lets you go and change that, change the key effectively on your side to any value you want. So that's the idea for encryption recovery. Then still kind of on encryption related stuff, ZFS. So we have an extra partition that's always created on the main disk, which we want to prepare for ZFS use. So to do that, we're just gonna be automatically creating an encrypted Z pool on it and put the encryption key on the main encrypted partition so that it effectively chains and we can unlock that Z pool on startup. This is not really what we would recommend most people use for storage because there's no redundancy on it. It's just gonna be on the main disk. the space is used as a Z pool. On modern NVMe SSDs, it's not too concerning. But for production environments, you're probably going to want to have additional disks and then set up a ZFS RAID on that, which we're going to be adding support for as well as part of another issue that I haven't created yet. I'm basically using issues kind of keep track of the thing that's a bit better defined in my head and then assigning that either to myself or to Matthias, depending on who's got time to do stuff at this point. Another thing kind of in the background, which was suggested by Lucas on my team, is support for Tailscale, which is not something I've played with very much. I'm my own ISP. I manage pretty complex networks. I've got my own WireGuard setup. I don't really need Tailscale. But it's pretty popular with a lot of folks, both at home and in smaller business environments. So that's where it can become, that's where it would be pretty interesting. And in those kind of environments, Tailscale is typically installed directly on every single system, both on the client side and on the server side, to then add them all to the tailnet and be able to access them that way. So unlike a more generic VPN that you would want to run on your gateway and then access everything through that, Tailscale, the recommendation seems to be to run it on every single endpoint, which in the case of IncusOS means every single IncusOS server should be able to directly join the tailnet. To do that, we would need to include the Tailscale client directly in the build, which is not particularly difficult. It's also written in Go. And then extend the network config to allow providing the authentication key so that we can join the network effectively. So that's kind of the idea. And it's, I think, something that would be pretty popular. In general, Tailscale is pretty popular right now. And given the system is redundant, there's literally no other way for anyone to do this. We're probably gonna be adding support natively. All right. People picking up on the fact I've got my own ISP. Yeah, well, I've been doing a bunch of server stuff, so at some point, moving data centers and moving providers was annoying because you kept getting different IP addresses and having to deal with that. So it ended up being easier, at least in the long run, for me to register through Aaron as my own ISP, get an AS number, get my own IPv4 and IPv6 allocation. And now I own that address space, so it doesn't matter what provider I'm dealing with, so long as I can get a BGP session with them, I can keep my addresses and stay in control. So yeah, that's a bit of a pastime, but that ended up being pretty useful. And that's also what's running all of the Linux containers infrastructure. It's all on my network. Cool. So that's where we're at now. Let's focus on services because that's kind of what we're here for. First of all, we're going to do the usual demonstration of where we stand, but not too much has changed, I think, on this side. So if we just go in the IncusOS folder, I'm going to go and first rebase my branch on what we just merged to have the new shiny API. Okay. Doing that, which is causing some conflicts. That's fun. Okay, yeah, that was expected. An extra rat was added there, so that makes sense. Okay, so system network is the new one that was added. We're actually gonna want it in alphabetical order, so I think something like this would be good. Okay, just gonna resolve that conflict real quick, and I hope the rest should apply. Yeah, we're good. Now let's go and build a new image here. Here we go. Okay, while that's going on, I'm just gonna show what the code currently looks like because there were a few small changes. So the addition of the initial service API is kind of all done in a single commit. For those who watched this last week, it was like a pretty early implementation of it. So it was basically hard-coded endpoints for NVMe and then calling in directly into functions on the NVMe side. I've changed things a bit now. So we've got an interface that we can see at the bottom here. So now every service is expected to have a get function, a start function, stop function, a way to get their struct for the state, an update function, and then an internal init function. And instead of directly instantiating the service, we now have a, let's load there. We've got a load function that we pass the name of the service to, and that gets us the service struct, which then means on the API side, we can do something pretty neat. So currently the list of services is still hard-coded. I've not put a function to fill data in automatically yet. But then instead of having an API route for every single service, we just have a generic one called API services endpoint. From that, then from the URL gets the name of the service, which then pulls the struct. And then once we've got the service struct, we can call get on it, or we can call update on it. In case of put, I've not done the update yet, so I was getting there. But basically, yeah, taking the data from the user, turning it into a struct, and then we need to call update here. So that hasn't been done yet. And yeah, on the API server, we just have a single entry here for all of the services in one shot. So it was just a way to make things a bit simpler, a bit cleaner, and it's going to make it easier to scale the number of services without having to copy paste the same boilerplate over and over again. All right, just taking a quick look at the chat. So there was a question about stability of IncusOS, but Gerard already responded that yeah, it's not released yet. It's at this point, I think we're probably around a month away to having something that we're happy with people using, as in it can self-update, and we're not expecting drastic changes that would break it. So there's another question around make it as easy to deploy as Canonical's microcloud. So I'm hoping to actually have it be easier because microcloud still needs you to deploy either Ubuntu Core or an Ubuntu system and then install microcloud, microsafe, microoven, and LXD. And after that, it's pretty automagic. With this, the idea is that you don't even need to do the OS install. So it's literally USB stick, plug it into 3 systems, turn it on, they install. And the clustering part, that's gonna be the next focus effectively. So once we've got IncusOS into a good state, that's gonna be the interesting part where I want the IncusOS API to be able to do some amount of discovery. So similar to the to what we have in microcloud with the MDNS discovery, but also having that effectively through the UI for those who prefer that. So it's for someone who's never played with Incus or with any of this, it should be possible to boot up those machines, get the IP address directly from the console, hit up that IP address, log into the UI, and then from that UI, being able to detect the other machines, cluster them together. And that would also include creating that internal project I mentioned in previous videos, which would then deploy some of the clustered services, like whether it's Ceph or Oven or a lane store controller or something like that, would be deployed effectively on top of Incus itself. And the bare metal OS, so the IncusOS in this case, would remain very, very clean, basically just running Incus. So that's the idea there. And then there was the discussion about the stream quality. Yeah. Okay, there was a question around, is there any way I can associate a storage pool with a project so that a restricted certificate can access that storage pool and upload ISOs? Yes, and I mean, yes, kinda. So the way it works is you can do a restricted project. And instead of a restricted project, you can do 2 things. First of all, you can put in restrictions, like this is VM only or container only or whatever. The other thing you can do is put limits, and limits can be put by storage pool. So any pool you don't want to allow within a project, you can put its limit to 0 and it's just gonna disappear. So that means you could have a project that only has one pool where it's got a non-zero limit on it. And then that will allow whoever has access to that project. In this case, you're mentioning a TLS certificate. So TLS certificates that's marked as restricted and bound to that project will only see that project, only see that storage pool, and can import volumes like ISO volumes with storage volume import. All right. So I think the image should have been built by now. Yeah, sure enough, it did. So just gonna run make test, and that's gonna get us the text console up there. And we're also gonna do the VGA console to just show that this stuff actually works now. So it's doing the usual first boot, secure boot enrollment, and now it's booting for real. Test IncusOS, and we want the VGA console. Oh, right. Not the best idea actually, because the script expects to be connected to the console. So if I connect to VGA now, I'm gonna kick out the text console. So I'm gonna wait until it's done installing and it's rebooted, at which point I don't mind if we kick out the text console because it will be fine. So anyway, I'm gonna do the VGA console in just a tiny bit. Looks like that console is not quite big enough because it keeps refreshing. There we go. So you've seen that before. It's basically just do the auto install from the install drive over to the actual system drive. There we go. Now it's gonna reboot onto the actual system here. And we can let it boot and show that the text console works, and then attach to the VGA console and show that we can get the same thing on VGA. Because obviously, up until now, we've been mostly developing things directly through, as an Incus VM, which means we've got access to the text console. But when you're gonna run it on an actual system, it's unlikely that you've got a serial console attached to the system that gets access to the text console. It's a lot more likely that you're gonna be looking at a VGA or HDMI console. Okay, so this is started up. It's gonna fail to talk to a provider because it's a local build. That's normal. So if we disconnect from there and then load up the VGA console, we can see effectively the exact same thing, but on VGA here. And then it gets redrawn every 10 seconds or something, which would, or 5 seconds, I think. So the time will increase, which is good, just to check the system is functional. Okay. With that, let's actually load up the applications. We can do make test applications. Actually, we can look at the VGA console. That's going on. Let's do that. Okay. Yeah, just maximize that. Test application. So now we're uploading the applications of both debug and Incus. And there we go. So it's applying them, starting application. We can see install application Incus, and it's initialized. So now we're good. And let's get a shell in there. So test IncusOS. Right, and config set HTTPS address. So just gonna make Incus listen on the network and generate us a token so we can talk to it directly from the host. Can do add IncusOS and then the token. Here we go. And we should be able to talk to it. Yep, works fine. Which means we can also talk to the OS API at this point. So OS 1.0. Yep, that works fine. We can go look at the services endpoint with the NVMe stuff. It's there, it's fine. And we should be able to access the new network API on system network. Yep, so that shows us the current network config. So that's just what you get if you don't feed any other network config. For any MAC address we detect, we just turn on DHCP and IPv6 Slack. So that's now up and running. We could use that to change the host name, for example. So one way to do it would be, mostly because we don't currently have like actual commands to mess with, otherwise we would be using an edit command or something. We can write it to file and then do domain, something like that. Call it my IncusOS as the host name. Okay. And should be able to do a put, and the data is then network JSON. Let's see what that does. Okay, so that's succeeded. If we get the data back, we've got a domain and host name, so that's good. And we should also host name CTL. See the same thing on the actual system here. Yep. My IncusOS, ECMTL, SQL.NET. So yeah, that's working fine. Actually, it's the wrong domain for where I'm at right now, but whatever. So that's working just fine there. Now back to looking at NVMe, since that's kind of the goal of this stream. Just need to resize this guy a bit. So we want it shorter. Oops. Okay. Something like that. All right. If we go look at IncusOS internals REST server, no, REST API services, there we go. So I mentioned earlier, we've got the get endpoint wired up. So that's what I was doing. Oops. Incus query, IncusOS, OS 1.0 services NVMe. Okay, that endpoint is wired up. If we do something else, it should fail. Yeah. If we do put, it will kind of succeed, but not quite, which is what we're seeing here. Could not and Marshall string into Go value of type services service NVMe. So, because it's the decoding aspect here, and then we need to actually code update on it as well. So we're decoding from the body and going into the struct. Not sure why it's malicious actually. Got a Marshall string into Go value of type services service NVMe. Oh right, yes, because I literally didn't pass any actual data. Yeah, that makes sense. Okay, so if I just pass, yeah, if I pass some empty data, then it behaves. Okay, so that endpoint works. It's just we're not calling update. So we need to actually do that then, which is gonna be, I think, just n.update, the request context, and then the actual struct that we're providing, and just the generic error handling then, something like that. Oops, error is already set. Okay, that should work fine. So make IncusOSD. That's fine. I'm gonna push that to this IncusOS in the root folder. And you might recall from the previous times the usual dance to get this stuff going. So we're bind mounting this thing and then can restart IncusOSD. Give it a few seconds to get the network up and running. Then see the endpoint, it's working. And if I do put on it, now it gets me not implemented. So that's fine. The not implemented should be coming from the services service NVMe endpoint. There's an update function here, which currently returns not implemented. So that's what we're hitting. That's expected. Now, one thing that's currently missing, but I'm not even sure yet how to do it, so I'll probably do it after this stream, is we need to wire this stuff up with the actual daemon state so that we can start storing some config within the daemon effectively. And that's gonna be needed here to just be able to tell whether the system is configured or not or what's going on. Because currently it's checking its on state to know whether it's enabled or not during a shutdown, which obviously is not gonna work very well if the state is not already preloaded correctly. Actually, I'm not sure, where do we do? Yeah, so currently we pretend that it's enabled here. So it's kind of hard-coded on startup. that's where this should actually load some existing state instead of just giving us a blank one like that. But let's just pretend we're not enabled. And so when we get an update, I'm going to do something that's probably a bad idea in the long run, but we'll fix that later, which is turn off the service. So disable the service. We're just going to do, and let's grab the error. So error, and we grab just n.stop with the provided context. So cannot. And then we need to effectively update our state to the new state. So this one is just raw, well, we'll just call it rec. And we need to convert that into the correct state. So we need to cast it to a service NVMe like that. If this doesn't succeed, then we need to return an error. Provided new state isn't of type. Well, actually, let's do something lower level, because this is not an error that should ever be possible. So just go with request type isn't expected service NVMe. Okay, and then we just want the type of rec there. Okay, so in this case, we've disabled the service, update the configuration. So we want to just set that to the new state and bring the service back up. So we'll just do start on this guy. And that should be it. And it's complaining about, so we're missing FMT and the first error is not defined. Let's change that. Okay. Okay, now it's fine. Let me just take a look at the chat real quick. Can we take advantage of cache tiering, or will that be too complex to implement? So probably. We've not worked on the storage API design yet, but the idea is that the storage endpoint should kind of resemble the network one, where you can define a bunch of storage devices and pools and the like. So yeah, we should, I mean, we're going to be doing basically just ZFS there, except for clustered LVM, which is its own beast. But on the ZFS front, we should allow for the usual set of parameters. So being able to do mirrors, RAISY 1, 2, is there like a 3? I don't remember. Just striping, and then configuring also cache and log devices. The question will be whether we want to start getting into actual partitioning as opposed to just consuming whole drives. I don't know yet. I'm kind of hoping for not, because that would make our lives a bit easier. If we need to start messing with partitions, it's a bit tricky, because if you push a new config, do you expect us to go and wipe your partitions? That would cause data loss. That's not great. It's easier to deal with whole drives, so we're gonna have to see what we do. But for a system that has like a couple of small SSDs that you want to use as cache, and then some spinning drives that you want to use for data, I expect that it would be quite easy to say, you know, mirror those two hard drives, mirror those two NVMEs. NVMEs go as cache, and the slower drives go as the actual backing for the pool. And then maybe you've got another even smaller SSD that you want to use for the log or something along those lines. it's not really clear yet. We're gonna have to see. Like it's one of those things that you can go down that rabbit hole extremely deep, and we're gonna try and avoid doing that while still providing kind of the best out of the box option. All right. So we've got the new binary. Let's go and do the usual dance now. So we need to stop IncusOS and we need to mount the binary there. Then we can push the new binary and then bind mount IncusOS to user local bin IncusOS and start the service back up. All right. Now that we've got that, let's go and do some more queries against this guy. So this time it shows enabled false out of the box. So that's kind of expected, which probably means, do we have anything under NVMe? We do not. Okay. Let me look at the code again. Oops. There. So is it during start that we go and create file things? Yeah, okay. So let's try to turn it on. If I turn it on, it should go on and generate the folder and the files and all that stuff. So that would be pretty good. Let's try to get that working. So that's the current struct. So we'll do nvme.json. Then go and update that. So we want config true. Actually, I should change something. We don't want to allow the user to modify the state, obviously. The only thing you should be able to modify is the config. So we just need to change that in the code. Do I still have it open? I do not. Come on. Yeah. So in update, what I actually want to do, we want to actually update just the configuration. So it's config that we want to update, nothing else. Okay, and need to go do that dance again. Stop, push, start. Okay. If we again grab the service, that's the current service state, and we just want to do true on the config, and then update it based on that. Okay, so that went through. And sure enough, we've got a folder and we've got our host ID and host NQN. So that worked well. Currently, if we go and do a get, we still don't get those fields. That's because we don't have the logic to fill them. So that's something to go and fix. Let's go and do that. So in get, currently, we just initialize like an empty struct. Missing. Okay, and then here we need to go get runtime details if enabled. So we need to effectively go with f state config enabled. So if it is enabled, then we should be able to fetch the other two fields. So retrieve host ID and retrieve host NQN. So for that, it's pretty straightforward. We'll just do let's grab host ID and just do OS read file. And I think we literally just outputted the path because it's that easy. So host ID. So if we fail with an error at this stage, we just fail. And otherwise we want state.state.host ID to be the string representation of this guy. And then rinse and repeat with the NQN. So NQN and set it there. That was easy. Let's stop it, push, start it. And let's see what we get. Not running yet. Okay, so it thinks it's disabled, which is normal. It doesn't have state, as you might remember. Even though we've got a state struct, there's no actual persistent state within a daemon at this point. So we need to turn it back on. So let's do put. And hello, why aren't you turning on now? Enabled false. So something failed. Don't know if it actually logged anything though. Let's try it again. No. And that also the query didn't actually show anything useful. So let's see if we can. Yeah, it's just failing with no error being returned. So that's actually unfortunate. Let's see if we can figure out why. So it's presumably start is failing. We know that the current state is enabled is false. Well, state config enabled. Yeah, okay, so that should be true given what's being pushed here. So we're getting the request. We're not getting any error here. Stop should fail. Well, shouldn't fail. It should just skip because there's nothing to stop. Yeah, state config enabled is false, so it just skips. That's fine. Then we set the config and we call start. And in this case, in start, the config should be enabled, so it should skip that. I'm not too worried about mode probe. That should not be a problem if they're already loaded. We don't care if it already exists, so that's fine. Then we start the file. If it's not null, we check for not exist and we create the thing. So that shouldn't be a problem either. This one, actually, hold on. That might be a problem. No, because it would be null, so that's fine. It would not run that. And then we run NVMe connect all, so maybe that's what's failing? No, it's not. Okay. Well, time to break out strace and see what's actually going on. Oh, my usual problem. I think every week I get caught by that one, which is I don't have the application enabled. So let's enable the applications. Applications.yaml. Let's do version 1. Applications. Incus debug. We do a table for the seed with the application list. I'll push that into test IncusOS root, and then we cat the seed into the seed partition. Okay. Let's see what happens if I restart the daemon now. Starting up. Application. Okay, so it's still, it has state, so it didn't do anything useful. Let's flush the state and do it again. Starting up. Time that's waiting for network. Okay, well, that's good. Try it again. This is kind of confusing. Why is it suddenly being unhappy with the network? Anyway, we can add the network in the seed as well. We had that added earlier. Where did I put it down? Because I've got NVMe here. Applications, NVMe. Okay, I remember querying the, is it in my home there? Is that where it is? Yeah. Network JSON, there we go. So I'm gonna just create a new seed. So blow away this one. Seed.ton will include both applications, YAML and network JSON, and then push that. As a reminder, we support both JSON and YAML on all of the files, so that's why it doesn't matter which is which. Let's restart this guy and see if that helps. Doesn't look like it will. No. Okay, let's blow away the state again and restart it. Oh, there we go. Now we're good. Okay, so this time we've got networking and we've got both of debug and Incus applied. Like what happens is that the seed is really a seed. So if I don't wipe the state, it's not being read again. So I had to do that to pick up the network config here. All right, so that machine is now functional and we've got strace, which is good because we're gonna need it. So let's strace the daemon and do the put and see what it does. Okay. I'm not looking for the actual on-the-wire response, so that would be next. I'm more looking for whether it's running anything. Okay, so that's loaded. It's picked up a couple of things here. So that's probably the subprocess for NVMe connect then. Or some other command. Okay, let me just write that out as a log. It will be easier to figure out. So exec in there. Did we exec anything useful? So yeah, we exec disconnect all. So that's stop being run. Then mode probe of all of them. Then we've got to connect all. Then disconnect all. Then a connect all. So what's going on? Why are we getting the same request multiple times effectively? That's slightly puzzling. Okay, let's just go. Like this feels like the update call is failing, obviously. Even the start seems fine. So let's just add some debugging in there. So let's do, I don't expect this one to fail, but actually I'm gonna just do a entry point 1. And then we do just log our way through, stopped and started. So just to make sure where we're at in this thing, forgot the import. So it's gonna do that, make, push the, oops, stop this thing, push the binary, stop it back. And if we look at IncusOS, that should be the log. So now if I do put, that should have logged some stuff. Why didn't it? Okay, is that a problem with the logging? Was it a problem with the code, or what's going on? So did we get anything on there? We did not. Okay, so that's not a problem on that front. I'm kind of confused as to what's going on now. REST, so API services, just gotta make sure that we do an update. Let's import slog in this one too, I guess. Log slog. Slog in API handler. Usually whenever you start having to do that kind of stuff, it's because it's really something very, very dumb that's wrong. But, you know, need to still figure it out. Okay, so getting ready to push this thing, stop it, and start it back. Again, get the journal, and this time, so if I do query and I just do get on it. Okay, what the hell's going on with the log? No, this is really weird. Just checking I'm pushing the correct binary. Oh, no, I'm not. Oh, okay, well, that's the issue. Never mind. I was pushing the seed, not the binary, so that's what's going on. That makes a lot more sense. All right. As I said, something very dumb. So that's been pushed now, which means if I do journal up here, query, yay, that's what we want to see. Put. Okay, so now we can see what's going on with put. What happened here? So that was get, that's fine. Then that's the API handler for put, or input, or in update. In update stopped, started. Oh, I think I know what's going on. Okay. In API handler, so I think put simply doesn't return a final response, which makes the client think something failed. I think that's what that's going on. Yeah, that's the issue. There's no sync response at the end. So in this case, we'll just do an empty sync response. There doesn't need to be any data. We just need to say that, you know, things worked. Oh, it's right. I don't remember our response times by heart. Let's just do that, I guess. Yes. Okay. Let's stop that. Push the binary. Start it back. Still with a lot more debugging than we need, but you know. Okay, it stopped, and then puts the state. Okay, it's still wrong. It's still showing that it's not enabled. Oh, well, okay, yeah, no, that actually makes sense. Never mind. As I said, like there is really no state, and by that I mean that we get a new instance of that struct during what we are when we are putting the details. That's getting a new copy of the struct, but then the next get query does too, so it's empty again. There's literally no state, so that makes sense. We can do a quick workaround for that just to make things behave, but that's gonna need a bigger proper fix of actually integrating with a state system later to fix that. Okay, so if we look at service, I guess what I can do is in load. We'll just do a map string service. We'll just do a map called discrete services, something like that. Then in here, we'll just do the if services is no, we'll initialize it. Okay. And then what we do is we check if we already have it, which would be services name. If we do, we return it. If we don't, we go through the whole thing, but then after initialization, we just throw it into the map. And it's unhappy with, yeah, don't need that anymore. Okay, so that just gives us some very bad but functional built-in state, which should mean we can actually have an object that we can mutate over multiple queries now. So that's kind of the point. Okay, put, yay. So that actually worked correctly. There's still a bit of work to be done on the strings. As you can see, they include a line break, so we don't really like that. Just need to go and fix that up, but that's going to be an easy one. So service NVMe, we need to import strings. And then if you go look at the NQN and the other one, strings.stream spaces. And same thing here. I think that takes care of line breaks, but we'll see. Trim space, I guess, then. Yes. Okay. Stop that, push the new binary across, start it back, and query the service. Just takes a few seconds to start up. There we go. So it's disabled again since it's not persistent state, it was just in-memory state. Turn the service back on. Here we go. Okay, so that's all good. Now we've got the actual targets. That's not implemented yet, so I can probably try and spend a couple of minutes on getting that going. I don't remember, do I actually have that example on my own? No, I reinstalled that desktop, obviously. So I don't have the example anymore on how to do that, but I do have it in another repo. Yeah, I've got a copy of that one, good. That's in cluster test. And is it in templates that we've got the NVMe stuff? That's in here. So that's gonna have the addresses of the NVMe's. Yeah, and then that needs to be pushed into the correct file. So let's go look at where it's going to be the right place to do this. Probably an update for now. Let's just do it in update. I can clean that up later. So if we update the service, look at the update function. We can actually remove all of the slog stuff. Let's do that. Right, and there was, okay, that's fine. So disable service, update the configuration, replace the targets. So that's where we're gonna be going through the targets and adding and like resetting the file effectively and adding them back in. And like we know what the targets should look like. Let me check what the struct for the targets is like. I don't remember. Transport address port. Okay. So let's do that. If I update the JSON for the targets, it's gonna be a list of structs. And we said we want transport address port. Okay. And yeah, wrong one. Okay. Transport is TCP. And the address is this guy. And we can probably figure out the port, but it should be the default one, I think. So let's just tentatively not do that, and then add the other two. So that's 1 and 2. Okay. So that's kind of what the struct should look like with the targets added. And then here I need to look at another repo called IncusDeploy and suball books NVMe and see how we actually render that stuff. It's through a template here, discovery.conf, there we go. And this one just does transport TCP transport address and not give details about the port. Let me actually figure out what the port is so we can include it in there. It's going to be slightly easier. So let's just go on one of the hosts. Wow, I've never connected to it since I reinstalled that machine. That's surprising. Okay, so NVMe TCP setup, there we go. There should be the port number somewhere in there, you'd think. IP, there we go. Port is, well, I'm assuming that's the port service ID, maybe. 8009. Do I have something on 8009? I do. Okay, so that's the port. Let's go and add that in there. Okay. Avoid all the space. Well, I mean, it's mostly for layout. I don't think it matters, but okay, let's add the ports to these two. Just fix the syntax here, there, here. That looks plausibly correct. Let's try to do a put. That shouldn't do anything because we don't have the server-side logic for it, but cannot unmatch all string into go value. Okay, so it's meta-less. Yeah, line 10 is wrong. Okay. Do I still have the JSON open? No, I do not. Line 10. Oh, right. Okay, so that's more like it. Is that valid now? Yes. Okay. And that went through. Okay, cool. I think if we do raw, it should show a normal response. Yeah, success. Okay. So we just need a server side now. The client side, we're good. And on the server side, as we said, it's going to be an update that we're going to do that. So replace the target. So we can literally, we'll wipe, well, we're going to just get a new copy of the file effectively. So f error os create of etc NVMe discovery.conf. And I think create does truncate for me. I'm just gonna go look up the doc real quick just to be sure. Like I don't want it to end up corrupting the file. I want it to be actually reset, but I think it does the truncate on create. Create documentation. It does read write. Yeah, that's what I would expect. But does it do or trunc? Yep, or read write create trunc. 666 by default, which is not good permission-wise. No idea why they would do that for permissions, but okay. So I just need to fix the permissions on it. All right, so that's the create. Then if we get an error, we return the error, obviously. We need to defer closing of the file. And then error again, chmod 600 on it. All right. And then for each of the endpoints, whatever they're called in here, targets, we need to actually add the line that they need. So it's in config.targets that we need to iterate. So we'll just do for target range state config targets. And then we're gonna do error format printf, and we're gonna print into the file a new line, and that's where the template comes in handy. So we want transport is the name of the transport. The address is the address, and TRSVCID, I think is the port. Is that what? No, that works. Hopefully. And then line break. Okay, so we need target.protocol, target.address, and target.port, something like that. And that should be it. Okay, it's not super happy. I gave it the file, I gave it the arguments. Why isn't it happy? One variable but returns 2. Oh, returns 2? Oh, I think it gives you a byte count of how much it wrote. Yeah, I don't care about that. And it's not protocol, it must be, so we must actually have used transport then to line it up. That's fine. And if we get an error, let's deal with it. Cool, so that built. Now let's stop this guy, push the binary and start it back up. Actually, I think I've got some more random slog stuff laying around that we should get rid of. Let's just go and do that. That can go away, can go away, can go away, can go away, can go away. We're good. Okay, let's rebuild and push the binary, start the binary, and then check what we have. Okay, and put success. Okay. All right. So we do have state. We've got the targets that are listed. And now for the question is, did we actually get a discovery file? Yeah, that's not going to be very valid. Let me go and fix that. Like, I guess connect all always succeed. It just didn't find anything with that kind of config in place. So let's just go and fix that one real quick. Yeah, so they're all, this one is an actual integer, so we should just do integer make stop this service up here, push the new build, start the service back up, and go play with query again. There we go, and then enable our stuff again, success, very good. And let's see the config, should be fine now. Yep. And we've got our NVMe. So that worked. Neat. So that's here. Now, if I turn it off, it probably won't go and clean things because stop doesn't know any better. I think I'm probably gonna actually move that object into stop and start. That would make more sense. So let's just do that quickly, then we can wrap up the stream. So if I go in here, the discovery, let me actually zoom that stuff back in. There we go, discovery.conf. So replacing of the targets, that shouldn't be done here. That should realistically be done on start instead. So because start is also what makes sure the folder and the config exists. So we only can do this stuff afterwards. So we want to put it here, generate targets. And in stop, what we actually want to do is here, once we've disconnected them all, we should also remove the discovery file. Like the host ID, auth we definitely do not want to delete, but the discovery file actually makes sense to delete. So that it doesn't get turned back on by accident, effectively. What's not exist? Yeah, this. Okay. So if we get an unexpected error here, we can return it. Okay, binary built fine. Now let's go and stop this stuff. Push the binary, start this stuff. Okay, and I'm gonna once again just put the state. Okay, that seems to have worked. NVMe list. Okay, so it didn't work so well. Okay, let's disable it. Okay, so in theory now it's disabled, so discovery should be gone, yet it still exists. Okay, something else is wrong. What's going on here? Enabled false, but it still has the targets. Okay, why is the file still here? I'm kind of confused now. So what's going on? We're entering this thing, we're calling stop. Stop should clean everything up. Then we apply the new statement to start, and start is supposed to go and create the file and run discovery. So, I mean, currently we're not enabled, so it wouldn't have done anything. That's fine. What's more puzzling is why start isn't working, I guess, then. Just checking what's in there, but like currently enabled. Oh, okay, so that's my bad. Never mind. If it's currently disabled, so that's why it's not doing anything. Okay, fine. So if I push it, still wrong. Okay, that's entertaining. What do we have now? Okay, enabled true. And obviously the file should still exist at this stage. Yeah. Okay, now enable false. Oh, no, that shouldn't be the issue. Never mind. I was just thinking of something, but no. Okay, so that should mark it as off now. Yes. The file's still here. What the hell? Like, it clearly modifies the struct. That's clearly working. But then it's as if it never called start and stop. Because if it called start, we would have an NVMe device. If it called stop, the file would be gone. And it seems to have been doing neither. So that's really weird. It's going to be time to add some more logging again because I've no idea what's going on. Huh? So let's add that stuff again. Update. Where's update? Okay. slog stop. Calling start. Okay. Let me just check something. No, so that should be fine. Okay. It's before we change the service state. Okay, so that's fine. Stop. Okay, sure. Start. Let's start with that, just to make sure we're doing something. Also make sure we're copying the right binary this time. Start, and I want to see the journal. Calling stop, calling start. Okay. So supposedly, like again, it should have in theory done the connect all, which I'm pretty sure it didn't, because if it did, we would see stuff. So it definitely didn't do that, because if it did call connect all, we'd see things. So I don't know what start did, but sure didn't do anything useful. What is the config right now? Okay, so right now, okay, it's actually normal that it wouldn't have done anything. Like stop would have not done anything because it's not running. Start would not have done anything because it's not asked to be running. Now let's put true. Push that guy again. Again, code stop, code start. State says running, says true. And we're not gonna see anything. Yeah. All right, so there's still something wrong. Let's try that. Just trying to figure out if like it looks like both of them are immediately skipping and not doing anything, which is kind of weird. But I wanna see it actually being reported. Okay. So yeah, enable true is what we want to see. Okay. Calling stop, calling start. Neither of them logged anything. So that's weird. That doesn't make any sense. Like I did compile it, I did push it. And come on. Okay, here. Okay, is there like any code in there that just returns? Like straight up returns? No. None that I can see. Okay. It's gonna be something really, really dumb. That's always where where I end up wasting our time, is always on very dumb things. Okay, calling stop running. I mean, ignore the fact that the log message is confusing, but effectively it shows that both of them ran the logic, which shouldn't be possible. So I'm just gonna get a clean state again. So if we get this state out, come on, enabled false. Okay. So if it's not enabled, stop should not do anything. Now, why is it saying it's doing something? Because that's wrong. Stop. Okay, so we get here. Why is state.config.enabled set to true when we query it and it gets set, it's false? That's what the hell. Yeah, it's clearly false. So n is not, there's a question about like whether I'm passing n around. N is reference to the struct that the function is on, so they all share the same n. So we don't need to pass it around. Okay, so we're calling, let's see, why are we calling that? Update. I mean, this one is gonna dump the down struct every time because that makes no sense. So just gonna dump that. Like until here, it shouldn't have the started flag, the enabled flag set to true in it. So we're gonna make sure we don't have anything that's still set enabled. That doesn't look like we do. Okay, let's go to stop this guy and push the binary and start it back up. Okay, journal, sure, and okay, let's see what we get. Calling stop. Okay, it's not happy with the way I'm passing it, but whatever. State whatever config enable true. No. Oh. Crap. Yeah, I think I know what's going on. Maybe. Yeah, I think I know what's going on. Okay, that's fine. Let's go and fix it. So we've got that struct function here, which returns the struct we're supposed to be filling. And instead of returning the struct we're supposed to be filling, I'm returning the actual reference to the struct. That's a bad idea, because now we're effectively overriding the struct directly instead of passing a new struct. And that would definitely explain what we're seeing. Service NVMe. As I said, something very dumb. It's always the case with those kind of weird issues. Pushing that, starting it back up, journal, and this time we should have something that works. So query state were enabled false. Put, that took a little while, that's good. So this time, stop skipping service not enabled, that's what we want to see. And then the new config enable true and start is running start. Okay, so that should mean NVMe list. Yes, that's good. Now, if we go and modify the JSON and we set it to false and we push the config, it should be gone. Yes. And discovery is gone. Yay. Now, if we turn it back on, just making sure the file actually gets created in that scenario. That was a bit too quick. Yeah, something didn't work here. Discovery was regenerated, but the connect all didn't work for some reason. What's going on here? Yeah, it shows start, running start, okay, but I didn't get the little delay that we'd expect from connect all, so it didn't run. Okay, not sure why. Let's turn it back off. Okay, so it's off again. Discovery is gone. NVMe list is empty. Now, since we're literally dealing with a sub-process in this case, strace is gonna be our friend. So let's go and dump that again. And gonna turn and just watch it work this time, just to be annoying, but yeah, that took a while. Pretty sure it worked. Let's just get another shell in there. But there might be some weird race thing going on with NVMe Connect All, which is not super encouraging if that's the issue. Oh no, it didn't work. Huh, okay. Yeah, no text did it. No less. Okay, fine. So it did run NVMe Connect All, so that's good. Let's see what that did. Okay, so NVMe Connect. No, not that. Yeah, here we go. Connect all. Cloning exec. So 8141 is the process that we care about. I want to see what's going on in that one. 8141 exit 0. Etsy NVMe discovery.conf no such file directory. Okay, so that's an issue, especially given it exists. Let's say it might just be an ordering issue in the start function. Okay, NVMe discovery, we're creating it here. Well, yeah, that's a problem, huh, isn't it? There we go. Sometimes the easiest solution is what's going on. Connect all NVMe devices. There we go. So it works better if you run the command after you've put the configuration file on disk. Alrighty, so this time it should work reliably. Actually, let me go and remove the debugging because I'm that confident that things are gonna work. All right. And pushing things, starting a daemon. Let's look at the journal, but there won't be anything particularly useful this time around. Okay. And if we query the state, it's not running, that's fine. Put is enabled, and it took a little while, and we can actually see in the journal that it did detect the controller. So we're good. Now let's edit the NVMe, set it to false, and apply that. Okay, it's gone. 3 controllers are gone. Just confirming, list is gone, discovery file is gone. Yay. Now let's go and edit that again. Turn it back to true. Push, that took a little while. That's what we want to see. NVMe list, we're good, and we've got the discovery file. Yay! So that's finally working the way it's supposed to, after I messed up a few times. So, changes that we have. Is there anything I need to get rid of in there? Nope, more logging. So that's what we've done today on top of what was there basically from last week. The update endpoint is there now, so that's good. There's a temporary cache situation thing I need to get rid of here. That stuff should be replaced by using our internal state mechanism instead. Then service NVMe is here, and we can see that now the get function gets the host ID and the NQN if the service is enabled. And then update was implemented to convert the data we're being sent, stop the service, apply the config, start it back up, which is not ideal for NVMe because that would potentially lead to drives we don't want to remove that would end up being removed. So there needs to be more logic to do it in a smoother way, but that's good for now. Then on stop, we clear the discovery file. On create, we generate the discovery file. So that's all good. And fixed my dumb little bug here of returning the actual pointer instead of returning a clean struct to unpack into. And we don't pretend that we're always enabled. So that's good. That's this stuff working. I think I just need to do a bit more polishing, as I said, like on the state side. And maybe I'll update the update function to not do a full stop and start, but to just check, like if the service is enabled and now it's disabled or vice versa, then yes, we will call stop and start, stop or start, depending, that's fine. But if all that's changing are the targets, we should just regenerate the list of targets and call effectively disconnect or connect on just the new entries instead of the entire bunch. To avoid disconnecting drives we actually care about. But that's it. Hopefully you liked seeing me try to debug some really dumb bugs along the way. But this is now basically functional on the NVMe over TCP front, and more of the infrastructure for services is in place that should be able to pretty quickly rinse and repeat with the others. As a reminder, some of the others are LVM, for clustered LVM, as well as doing IncusOS, which is very similar to NVMe over TCP as far as how it's implemented, and then Open vSwitch with the oven integration also needing to be added to that. So that's going to be the next piece. Is once I'm happy with the structure, including the state and that those services come back up correctly on startup and that kind of thing, then it's going to be pretty quick to go and add the missing pieces. All right. Thanks a lot for watching this hour-and-a-half live stream. Sorry for the connection issue at the beginning. Not too sure what was going on. Maybe a bit of a glitch on the YouTube ingest side or something. But I think the rest of the live stream has been pretty solid. So all good. And yeah, if you've got any questions around any of this work, feel free to leave them down below or go on the community forum. You can also keep an eye on the GitHub repo for any of the ongoing like planned issues or any of the work we've got there. That's the best way to keep an eye on IncusOS. And I'll see you in the next one. Thanks a lot for watching. Bye.